All right, hello once again, Jeff Scott of Rankin Technical College. As part of the Rankin Technical College Application and Website Development, or AWD1100, Programming Fundamentals in C# course, I'm doing a series of video presentations based on the PowerPoint slides for the textbook for the class, which is Murox C# 7th edition. I am now in the middle of going through Chapter 8. This is Part 2 of the presentation, so I'm going to jump back into the presentation, and here I am. So I left off last time talking about a new kind of loop we have not looked at yet, which is the for each loop. So to get some knowledge, so to speak, about a new subject, I went out to the Microsoft Docs on docs.microsoft.com and typed in C# for each loop. And notice they've got a using for each with arrays C# programming guide. All right, this is always, again, between this and W3 schools, they're pretty much my go-tos. So the for each statement provides a simple, clean way to iterate through the elements of an array. So here's an example. I'm going to grab their code, copy it to the clipboard, and I'm going to come down to here, and I'm just going to paste it in. All right. And there is absolutely nothing wrong with what they've done there. Okay? Works just fine. But I'm going to go, it's going to look a little weird, but I'm going to copy it in again. And then let's talk about how to do this using a loop we already know. So we could say for int, I'll use their I again. Okay, so int I equals 0, I less than numbers dot length plus I. And guess what? We're going to get the same output. Now, we haven't really looked at doing things like this. Don't worry about that, please. The point is I'm going to get the exact same output. But notice the for each has got a lot more elegant type of structure than a regular for loop. Here I'm again creating a brand new variable called I, but I'm saying that I exists in the numbers array. So a lot of people with arrays like to use for each because they find that it's a more compact type of structure. If you find that that's easier to use, by all means do that. If you think this way is easier to use, by all means do that. Again, you should be in your first year in this program programming for understandability. You shouldn't be programming so much to try to see how you can save a line of code here or there or whatever. You have to understand what you're doing because you are building those concepts that you're going to be using throughout your career here at Rankin and your career once you leave Rankin. Okay, enough of this sermon. So let's jump back in. That was my little shtick, so to speak, on the for each loop. They also show it in here and how you can use it. Very similar to the example I just showed you. All right, there they're working with average. Guess what? I already showed you that. Okay, I already showed you that earlier. There's a for each statement rather that does totals. Again, a little more elegant. All right. Next, they go into what's called a rectangular array. This is an array of arrays, for lack of better words. It's a 3x2 array. And it always has surprised me that people tell me they don't understand this. So what I'm going to do is I'm going to come in here, make this a little wider, and I'm going to say I want 3 rows, 1, 2, 3, and I want 2 columns. That's a 3x2 array. 3 rows. All right. And I did it wrong, didn't I? 3 rows, 2 columns. So there are 1, 2, 3 rows, and there are 1, 2, 1, 2, 1, 2 columns. So each row has 2 columns. That is basically a multi-dimensional array. Now, when you do it like this, Notice you have to put the comma in there, so it has to know how many dimensions there are. You can always tell how many elements there'll be by multiplying. So 3 times 2 is 6, so there'll be 6 elements. This is the way that you actually refer to them. It's 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, and 2, 1. Looks a little ugly, all right? But it actually, there are times when using a multi-dimension array makes a lot of sense. So for instance, here's one. They've got products, a C# product, and that's its title. A C# or a Java product, and that's its title. An ASP.NET MVC, and that's its title, etc. There's other ways you can create arrays of strings. They show one here. They show another one there. All right. Now, you might be looking at this and say, hey, you're skipping this, you're skipping. I'm not trying to skip anything, but I'm trying to hit what I consider to be the high points. All right, because we're going to go over a lot of this stuff in class as well. This is just to provide additional information for those of you who feel you might need it. All right, there's a get length method here, as it says, to get the number of rows or the number of columns. Okay. And they've got some examples. I'm not going to go through those anymore. You can also have what's called a jagged array. With a jagged array, you have a different number of columns in each row, or potentially you do. All right? Let's think about an actual use for this. Okay? Let's assume, in the example here, with this numbers 0, or this thing, it's going to be a new array with 3 elements. So let's say this was a class and this was 3 tests. Now the next class, all right, they've taken 4 tests. And this class has taken 2 tests. All right, we're not going to work much with jagged arrays, but it's nice to know that they're available to you if by chance you have different, you have to have different number of columns in different rows, okay? Here's one you could use. So let's say, for example, maybe this isn't a great example, but let's pretend, let's not even look at what's here, but let's pretend that we had here 2 different arrays, and here we had a title, and the author. A title, and the author. So let's say that we said this author right here authored 2 books, this author authored 4 books, maybe this author only authored 1 book. There's a lot of ways that you can use this. They show you an example here. All right, so the way this is set up, you've got row 1 has got 3 columns, row 2 has got 4 columns, or row 0, I should say. Row 0 has 2 columns, 0, 1, 2. Row 1 has 3 columns, 4, 5, 6, 7, 0, 1, 2, 3, and etc. You hopefully get the idea. All right. All right. Common properties of the array class, part 1. Let's again go back quickly to our friend here out on Microsoft Docs. So I'm going to go back to docs.microsoft.com, and I'm going to type in here C# array class. And whoop, lo and behold, there it is. Some people like to go here, which is kind of the terse documentation. If you go in here with the language spec, typically you get a few more examples, and even more than that if you go to the programming guide. They all blend or bleed into one another anyway. So here are some examples of using an array, big, whoop-de-doo. But if I go down far enough after the remarks, here's some properties that arrays have. All right, here's some methods that you can use on arrays. I'm going to show you a bunch of these after I get done with the lecture on this chapter, and we actually go through a couple working programs. All right, don't need that up anymore. All right. There it is. Okay. We already talked about the length property, and I've even shown you the get length. So these I very rarely, if ever, use, but length is used a lot. Things you can do with arrays, you're going to see a lot of these in the examples I'm going to give you shortly. You can copy some or all values from one array to another using the copy method. Binary search, give you my story real quick about binary search. Years ago, I was at home and I was watching during the summer, I was watching The Price is Right. It was before Drew Carey. We had a guy named Bob Barker. And he had a woman up there, and he said, you can win this. And they showed a refrigerator. And she had 1 minute to guess the price. She said $700, and he said higher. She said $701, and I thought, you're not going to win. But imagine, for example, that I want you to guess a number between 1 and 1,000. Now, you could make random guesses. 367, and it's higher. 57, and it's higher. 512, it's lower, etc. But think about a more rational way of doing this. Let's assume for a second, I'm making this up. Our number is 731. So we say, make a guess. And I say 500, and you say higher. So right now, with one guess, I have now eliminated half of my possibilities. So I know that the number between 1 and 500, try that again, between 1 and 500 are now eliminated with one guess. Now I say, so I cut that in half again. I say, okay, 750. And you come back and you go, nope, lower. So now I know that 1 through 500 and 750 through 1,000 have been eliminated. In other words, this up here, when we did this, this was 50% of the numbers have been eliminated. Now with two guesses, 75% of the numbers have been eliminated. So I go and again, I cut this in half. So 500 and 750, what is that, 1250? So I say 625. And I'm told, nope, it's higher. So now I know that I've eliminated 1 to 500. I've eliminated really not 1 to 500, 1 to 625 have been eliminated, and 750. So now I know that the number must be between 626 and 750. And if I do a subtraction there, what's left then, it looks like, are 124 numbers. All right, so 124 numbers means that now 87.6, I think, percent in 3 guesses, I've eliminated all those. So I cut it in half again. All right, so what is that, 1375? So I'm going to say, let's just say, let's say that I say 700. And I'm told higher. Now I know that all the numbers from 1 through 699 or through 700 have been eliminated, and 750 through 1,000 have been eliminated. So I know it's got to be a number between 701 and 749. So I've got about 49 things left. Okay, so I again cut it in half. And I say 725. And I'm said, nope, it's higher. So now I know 1 through 725 and 750 through 1,000 have all been eliminated. So I do it in half again. So I know it's got to be between 726 and 749. All right, so I'll say 737. And they say lower. Well, now I know that everything from 1 to 725 and everything from 737 to 1000 has been eliminated. Now, it may not sound like much, but after making 1, 2, 3, 4, 5, 6 guesses on a number between 1 and 1000, I know that that number must either be 726, 727, 728, 729, 730, 731, 732, 733, 734, 735, or 736. So in other words, by making 6 guesses, I have eliminated, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So by making 6 guesses, I have eliminated 989 possibilities. That's not bad. And if I keep going, all right, so I know it's between these two, and I guess again, and I say 731. Okay? And I'm told, nope, it's higher. I'm just going to grab this. So now I know that everything from 731, so out of the ones that I have here now after 7 guesses, all right, oh, I said 731 here and it's higher. Let's say we said 730. We'll make it like that, 730. All right, so everything, and we're told that it's higher because it's 731. So really everything between 1 and 730 has been eliminated. And everything between 737 and 1000 has been eliminated. So these are all gone. So was that one. So these are what's left. So in other words, now I've made 1, 2, 3, 4, 5, 6, 7 guesses, and I've got it down to 6 numbers. So in other words, I've eliminated 994 of my numbers. All right, I do it again, and I say, I know you get the idea. I get that. But I come through here, and I say 733, and you say lower. All right, now I know everything from 733, so I know what's left, 731 and 732. In other words, I've now eliminated 998 possibles out of 1000 with 1, 2, 3, 4, 5, 6, 7, 8 guesses. So I'm either going to guess it in 9 guesses if I say 731, or in 10 guesses if I say 732 first. All right? So why am I telling you that? That's how a binary search works. Okay? The sorts things into ascending order. Okay? I'm not going to go through the get upper bounds, etc. There's a sort example. You can do it on both numeric and non-numeric. All right. Now, if we go through and we take a quick look, again, I don't want to go too far in any one of these lectures, but if we take a quick look, as we did here, you'll notice that there's a bunch of sorts. And there's also a thing that's called reverse. where you can sort to get them in ascending order, then run a reverse to get them in descending order. Okay. All right, there's a copy for an array. I'll let you look at that. We will go over that in class. You can pass arrays in as arguments to routines. You can receive an array back. Okay, and they've got some examples here. Now they go through the params keyword. I don't want to get too much into this because you're probably going to find it too confusing. I know I did when I first started to learn this. All right. All right, so they talk a little bit in here about null references. Again, I'm not going to go into that. I will go into it in more depth and breadth of coverage, all right, when we go into this in class, okay? All right. They've got in here that you can use ranges, 0 to 3. Notice the dot dot. We'll talk about that in class. You can use these ranges and for each loops if you only want to go through part of an array. All right. All right, it says how to use the index and range types. There's a lot of different ways that you can work with ranges in here. I'm not going to go through all of this in a lot of depth and breadth of coverage. I will do that in class. All right, you have my word on that. So I am now at 22 minutes. It's a little early, but what I'm going to do is I'm going to stop because now we're going to get into regular collections. So I'm going to stop right here with part 2. When I bring it up, I will finish the chapter with part 3, talking about collections. Now, they say how arrays and collections are similar and how they're different. An array, in my opinion at least, is a type of collection. We'll talk about that when we get back. Then when we finish that, I'm going to write 2 applications for you that use arrays. These are not in the textbook. All right, one will be a console app because we can do it fairly quickly, and the other one will be a little bit more in depth. But I'm going to write them both so you can see how we can work with those. So I'll be back to talk to you about collections in just a couple moments.